So I have started the recordings. You may proceed. I hope the screen is visible to you all. So today we will be doing
Yes.
PYQs from January and May term quiz one. So yeah,
Okay, so let's get started. This is my voice fine? Like, is my audio level fine from my end?
perfect, perfect.
Okay. Okay. So May 24 quiz one. Okay, for maths two. Okay. So you have been given four subsets of R4. Okay. So one is this subset, one is this subset, and one is this subset. So first of all, always know whenever there is a span of a subset, any span of any set is always a subspace. Is this part clear? Span of any set is a subspace. So basically span and subspace are the same thing. Span is equivalent to subspace. Clear? Anyone any doubt here? Hello? Am I audible?
No,
Good.
no.
Yeah. Good.
So span is basically a subspace. Okay. So just let's see the question. Yeah. So it's saying W is a subspace which is given to you. Okay. So it is a span of this set. Now you have been given two more sets, B1 and B2. In both B1 and B2, there are three elements, three vectors each. Okay. Now you have to select the correct option. So both B1 and B2 are bases for W. So first of all, W is span of these vectors. Okay. So what you should do is, okay, you should first of all try to find the basis of W. Okay. So how would you do it? So there are two ways. You can just place these vectors as columns in a matrix and perform row echelon conversion. But instead of placing them as columns, I would advise you to place them as rows, because I told you in last session that when you are doing row echelon conversion, okay, so the row space is not affected by the sorry, basis for the row space is not affected by the row echelon conversion. So at the end of the row echelon conversion, if you get AREF, then you can take basis from this as well as basis from the original matrix also. Okay, so just place them as rows instead of columns. Both would work. Okay, but if it is a multiple choice question, then you would have, again have to like verify. Okay, so better to place them as rows. So minus 1 1 0 3 1 2 0 3. Then so we are right now talking about W, right? 2 2 0 10. Okay, so let's perform row echelon conversion. Okay, one more thing, before performing any row echelon conversion, just try to see whether any row is linear combination of other rows. So if you see at one glance, 2 minus 1 1, if you add these three rows, you will get this fourth row. Can you see that? Just add them. 2 plus minus 1 plus 1, that is 2. Then
Yeah.
this is 0, this is 10. So you can directly see that row is actually, fourth row is actually a linear combination of the other three rows.
So that
Okay.
can be repeated.
So now quickly see the options. B2 has all the three vectors from this only. This. Okay. Is this part clear? So, but we need to
Yes.
do it. We need to do this conversion anyway. Because see why? Because it could be that this subspace is only two dimensional. That is, only two vectors are linearly independent. So you have to check all these options. So better to go with the conversion itself. Okay, so let's do it. So first of all, let's start. So this is a pivot 2 minus 1 0 4. So you know what we need to do is we need to create a one here. Okay, but I've told you that there are two conventions. That is, it could be either a one or any non-zero number. One according to our IITM course material and any other non-zero number according to other references. So, yep. So let's do it. So
So we can rearrange the rows, right?
yeah, but right now we have a non-zero number here, so we need not rearrange the rows. Okay, because there is a non-zero number at the pivot. So what I'm going to do is I'm going to scale this. Okay, so I need to hurry. Okay, so I'm going to scale this with 1. Okay, so this will become first row with 1 by 2. So this will become 1 minus 0.5, then 0, then 2. Okay, then minus 1, 1, 0, 3. Sorry, this is plus 1. Plus 1, 2, 0, 3. Then 2, 2, 0, 10. Okay, now now we have to start cleaning down this pivot. Okay, start cleaning down this pivot. So what would be the operations? So I'm going to do like all three at once. Okay, so 1 minus 0.5, 0, 2. Okay, so first I'm going to convert this to
Add
0.
it.
So what should I do? I should add.
Add it.
So I'll add first row to second row. So this will become 0. Then this will become 0.5. Then this will become 0. Then this
5.
will become 5. Okay, then I'm going to subtract first row from third row. So this will become 0. This will become 2.5. This will become 0 and this will become 1. Okay, then I'm going to subtract 2 times of row 1 from row 4. So this will become 0. Then
1. 1.
this will become 3, right?
Oh,
Because I'm
3.
subtracting 2 times of row 3. So this will
3.
become 3. Then this will become 0. Then this will become 6. Okay, so I've converted all zeros here. Okay, fine. Okay, then I need to convert this to 1. Okay, 1. So what I'm going to do, I'm going to scale it by 1 by 0.5. So this will become 1, this will become 0, and this will become 10. Okay, then 0, 2.5, 0, 1, 0, 3, 0, 6. Okay, now I'm going to start cleaning down this pivot. So this will become 1 minus 0.5, 0, 2. Okay, so this will become 0, 1, 0, 10. So I'm going to subtract 2.5 times of row 2 from row 3. So this will become 0, 0, 0. 2.5 times from this would be
Minus 24.
minus 24. Then this will become 0, 3, 0, 6. Okay, yeah, 9. Okay, I should have converted this also. Okay, 0, 3, 0, 6. Okay. So this will be subtracting 3 times of row 2 from row, sorry, 3 times of row 2 from row 4. So 0, 0, 0, and minus
24.
24.
Minus 20.
Okay, now you can see I have cleared down this pivot. Now there is no pivot in this column. Okay, so now my last pivot will be here. So what I need to do is I need to first scale it by minus 1 by 24. Okay, so I'm going to directly write it. Okay, all those steps. I mean 0 minus 0.5, 0, 2, 0, 1, 0, 10, 0, 0, 0, 1, and 0, 0, 0, 0. Clear?
Yeah.
Okay,
Yeah.
is this part clear? So now this is anyone any doubt here?
Yeah. How did that last row become 0?
Okay, so see, the thing is I performed multiple steps. So suppose first I, like, what did I do is I first scaled this row by minus 1 by 24. So this will become 1, yes or no?
Yeah.
Then I subtracted 24 times of I added 24 times of row 3 after conversion. After it has become 1, I scaled it by 24 and
Got
added
it.
here. Okay,
Got it. Thank you.
this has become 0. So now there are 3 pivots. Okay, so fine. So now you can see that first of all I did not perform any row exchanges there at all. I did not perform any row exchanges anywhere because see, the thing is why I did not like try to do row exchange for this, because all the columns have 0 in this place, so no exchange can do anything. Okay, so that's why I jumped onto this. Is this part clear? So
Yeah.
this is pivot, this is pivot, this is pivot. Okay,
So
so
in case
now
we do row
yeah.
exchange, then the span Whichever we
See,
take for basis will be different, right?
no. See, the row exchange we only do when I can make a non-zero entry here by exchange. But you can see that no row exists which can change. Anyway, I mean anyway, if we like start doing this, then we do not tamper with these two. Clear? I can only exchange from lower row. So if it was a 1 here, then I would have switched it. Okay. If it was a 1 here, if it was a 1 here, then I would switch these two rows to bring a 1 here, and then I would start cleaning down this pivot. Clear?
Yeah.
I would try to make it non-zero. If not possible, then I would move to the next pivot position, which is this. Clear? Okay, so this is the yeah. So what are the bases for this row space? Okay, so
Yeah.
first of all, this vector, this vector, this vector, or you can see that there is no row exchanges, so I can directly like take from the original matrix also. So which is this vector, and this vector.
Yeah.
So if you see, these are the three vectors. So B2 is definitely a basis for this. Okay, what about this? So what you need to do is, see, now if you see in B1, these are your standard basis vector, and standard basis vector always occur in reduced row echelon form conversion. So if you do reduced row echelon form conversion of this, that is cleaning up the pivots, then you know that uh, first of all, row echelon form of any matrix is always unique. So I don't even need to perform the operations. I can directly write it 0 1 0 0 0 0 0 1 0 0 0 0, because I know it will be cleared anyway, right? Upwards.
We done these all concept yesterday session,
Yeah,
right?
yeah. Everything I have covered. Okay, so I can directly see. So these are my vectors. If you see, these are present in this B1. So 1 0 0 0 1 0 0 and 0 0 0 1. Can you see these three vectors?
Yeah.
So B1 and B2 both are bases. B1 and B2 are both are bases for W. Clear?
Okay.
Okay. Now this question. Okay, I am relying on the fact that you attended
B1 and
yesterday's
B2.
session. B1 and B2 both are bases.
Yeah, okay.
Okay, for W. Why are they basis for W? Because W is a subspace span of any set. Because see, if you don't know, like you are wondering how come this span of this set, how come we are finding basis for that? Because span and subspaces are equivalent. That is, subspaces are spans. Clear?
Yeah, clear.
That's why we are finding basis. Okay, consider the system of linear equations. So I'm relying on the fact that you know whatever we covered yesterday. Clear? So
At
consider.
what situation we
Go
will
on.
take a column as vector as column?
Sorry.
At what circumstances we will take vector as column? Now you have taken it as row, right?
See, you could have taken them as columns also, but
Okay.
the thing is, when you like suppose if it was a multiple select question, suppose these options, these were not given, okay,
Okay.
and they asked you to find basis, okay, they
Okay.
asked you to find basis, and there were multiple select questions, multiple options. Then if you place them as columns, then what would happen is at the end you will get some row echelon form matrix. Then you would if you remember from yesterday, you would have to go to the original matrix corresponding to the columns in the reduced form. Whichever had pivots, you would have to take it from the original matrix. So you might be able to mark one option, but there might be another multiple option which was basis for same, because you know that any subspace has not a unique basis. It can be like multiple bases, infinite bases actually. So if you place them as rows instead, then you can pick basis from here also, from the reduced matrix as well as the original matrix also, given that you have tracked the row exchanges if there were any. So you would be able to check every option. Clear?
Yeah, clear. Thank you.
Okay.
Sir, one more doubt.
Yep.
Sir, so the span of any span of any
Yeah, span of any set is a subspace.
yeah. So the dimension will always be less than the dimension of the entire space, isn't it?
No, it depends. Like if you take span of three, see there are three vectors. So if you see these all vectors are from R4, but there are only three vectors. So span of this set will be a three-dimensional subspace in R4. So if
Yeah,
there were
R3.
four independent
R4,
vectors,
R4.
if there were four independent vectors, then it would have been R4 itself. So its dimension will be same as R4. Clear?
Yeah, okay, sir.
Okay. Now consider a system of linear equation. So I have already explained you yesterday this very well. Okay. So A is the coefficient matrix. Which of the following condition guarantees that system is consistent for any B belongs to Rn? Select all the true statements. So A is a diagonal matrix. A is a diagonal matrix. I don't know how this question is there because I mean you need to know like okay, just wait. Okay. So A is a square matrix. Fine. Okay. So A is a diagonal matrix with non-zero entries. So you know that when there is a diagonal matrix with non-zero entries. Okay. So first of all there is zero here, and there are non-zero entries here.
Yeah.
Okay, for any n cross n matrix. Okay, so this is how we usually represent a diagonal matrix. That is a big zero above and below the diagonal. So you can see all my elements on the diagonal are non-zero. This means that determinant of A is that is product of diagonal entries.
Yeah.
If they are non-zero, this implies that determinant is non-zero, right?
Yeah.
So okay, so so in that case there will always be a solution. Getting it? Anyone any doubt in this? Why there would be a solution? Why there
Yeah,
would be a
because
solution?
diagonal element are not zero.
Determinant is non-zero, right?
Yeah.
So
So
consistent
obviously
system.
determinant is
Uh,
not equals to zero.
I will tell you one thing. See, the thing is,
Diagonal is the leading entry and it is dependent variable.
see, the thing is, A matrix looks something like this. Suppose the best example we can take it as identity matrix. Okay, why? Like I will tell you from subspace point of view. Okay, so you know that there is some x, okay, and there is some b. We don't know what this b is. Now you know that all these columns are independent. I mean, there are four pivots, right?
Yeah.
Yeah,
Yes or
right.
no?
Yeah,
Now,
right.
okay, suppose so. What is the dimension of x? 4 × 1. Yes or no?
Yeah.
So
Yes.
A, B, C, D. So can I write this part as A times of 1 0 0 0 plus B times of 0 1 0 0?
Yeah,
See,
yeah.
have you seen this 0 0 1 0? How I'm writing this? See, A with first column plus B with second column plus C with third column plus D with fourth column. So if you see, this is a linear combination. Is this a linear combination of four independent vectors?
Yes.
So this means that this is a span, right? This is a subspace. This is a span. Linear combination is a span, right? So this means that what is the dimension of this
4.
4? This means that this is the entire R4. Yes or no?
Yeah.
See, all these vectors are in R4, and I have four independent such vectors. So this span is actually R4 itself. Yes or no?
Yeah.
Yes.
So B is also a vector in R4. See, B is a vector in R4. Rn right now, but in this case, B will be in R4. Yes or no? B is in R4.
Yeah.
So I can, since I am spanning the entire R4, I can easily get B, right? B, because B also lies in R4. So I can combine these vectors. I told you yesterday, we can combine four independent vectors in R4 to get any vector in R4. So this will always have a solution. Clear? Is this clear?
Yeah.
Okay. So this is the subspace point of view. But the thing is, see, if there was a zero here, okay, then this would have been a three-dimensional subspace. Then in that case, it could be the case that B lies outside that
सर वो
three-dimensional
देने के बाद
subspace
मैं
now.
जो जैसा बोल रहा है उसको देख के
Hey,
आप
First column
whoever
is
this is,
first column
please,
is A
please
span of
mute
A.
your microphone. Whoever this is.
Background noise. Yeah, there is a background noise.
बोल दो
Is this guy?
Yes. Yes.
Okay. Okay. So it could be that if there was a 0 here, it could be that B lies not in that subspace. So if
So
this was
it's
R4,
mean so it's mean first column is
yeah,
span of A, right?
span of a, yeah, column span of columns of A. So see, it could so if there was a 0 here, it could be that B lies somewhere outside this 3D subspace in R4. In that case, there will be no solution. Clear? But since this 3D subspace is itself, I mean this subspace is itself R4, B will always lie inside it. So that's why it will always have solution. Clear? Is this part clear?
Yes.
But anyway, if you have a system in which A is a square matrix, okay, just remember this. If you have a system AX is equals to B in which A is a square matrix and the determinant of that is non-zero, then it will always have a solution. Clear? Is this part clear?
Yeah, clear.
Yes.
That follows actually from this only. That result is result of this only. But you can just remember that result. I mean, if you don't want to understand. Okay. So at least one column of A is okay. So it is saying so it has said that AX is supposed to be always have a solution. That is determinant of A is non-zero. Now, first option is correct. Okay. At least one column of A is linear combination of other columns. So if one column of A was linear combination of other columns, then after row echelon form conversion, this column wouldn't have a pivot. In that case, determinant will become 0. Okay, so this option is wrong. What? Go on.
What is that?
Yes, correct.
Okay. So if any column was
Sir,
linear
can you
combination of
repeat this?
so
Can you repeat?
Oh, yeah.
if any column was linear combination of other columns, then determinant of a matrix becomes 0.
0.
If you remember from determinant properties, you can add, suppose this C3 was 2 times of C1 plus C2. So if you just subtract 2 times of C1 from C3, okay, and
Yeah,
so
okay.
C3 minus 2C1 minus C2, then this would become 0 vector. So in that case, you will have a 0 column, total column, and if you expand along this column, you will get determinant as 0.
0.
Clear?
Yeah.
Yeah, 0.
Okay, I hope this was clear. Okay, so this option is wrong because this implies that determinant is non-zero. This implies, okay, this implies so this is the information given to us in the question. So this is in accordance to this, okay, diagonal
Inconsistent.
entry with non-zero entry. Yeah, consistent. It is set consistent. This means that
Yeah,
determinant
system
of
is
A will be
consistent.
non-zero. So this is correct with that. This is wrong with that. Okay, B is one of the columns of A. So this is true. I told you. Okay. No. B is, yeah. So B can be one of the columns of A. Okay. So
Yeah, can
okay.
be. Yeah.
One more thing. Suppose if B was, suppose I have C1, C2. Can you tell me the unique solution if B was one of the columns? Suppose this B is the fourth column. So what will be the solution? What will be X? So this is an extra question. What will be the X? What will be the solution instance? Would it be 0, 0, 0, 1? Is this the solution instant in that case?
X,
If B is one of the columns of it.
X or
So this is a good question they can ask.
How
Suppose there are 3 columns and B is the fourth column. So in that case, would this be the solution instance is equals to B?
So X4 is 1.
What is
Yeah.
B?
I just any. So I have written B here and I have written B here. So if I
So
linearly combine these columns, 0 times of C1 plus 0 times of C2 plus 0 times of C3 plus 1 times of B1. So isn't this the solution instance?
Kramer
yeah,
solution.
1.
Okay, so solution instance is this vector 0, 0, 0, 1, this R vector in R. This is the solution instance. Okay. Okay. So now fourth question. The reduced row echelon form of A has no 0 rows. Clear? It would have all the pivots, so no row will be there, which will be all 0. So this option is also correct. A has at least n minus 1 linearly independent row, this means that at least one row, that is one row, is linearly dependent. So in that case also determinant will become 0. So that is not in accordance with this information. So this is wrong. Clear?
I couldn't understand the third option. B is one of the poles. So, okay.
Okay. Okay, fine.
Before that, I want to understand the meaning of at least. According to me, at least means minimum n
Greater
plus
than
1
equal
are
to.
there. Can you
Greater than
repeat?
equal to. Greater than equal to. At
Yeah.
least means greater than equal to.
Yes.
So
Yes.
n minus 1 is also included in that case. So this means if suppose I am starting with n minus 1 and my last case will be n linearly independent row. So in this case, see, greater than equal to, right? So it will include the n minus 1 as well as n. So in this
Okay.
case, there will be one dependent row. In that case, determinant will become 0. So that is not in accordance with us. With
Equal to.
what is
Yes.
given.
Got it. Got it. Got it. Thank you.
So many competitive exams like GATE, they always like try to trick you on this word, at least.
Yes. Yes.
So you
Yes.
have to be very
Thank.
clear when answering such questions.
Yes.
Okay.
Thank you.
Now, yeah. So what I was telling is, see, the thing is, this AX is equals to B. Okay, this system will always have a solution if B lies in column space of A. So if you have, suppose A with columns this, then column space of this matrix is nothing but linear combination of column vectors. Yes or no?
Yes.
So if I take one of the columns as B itself, okay, X is equals to B.
B means
Now,
solution, you are saying, like in augmented
so
matrix we are taking.
yeah, we are checking whether there's exists a solution for this system where B vector is given. Now, if I take B vector as the column itself, can you tell me a combination of columns? Can you tell me the coefficients of columns such that I will get B? So is this a possible column? 0 times of C1 plus 0 times of C2 plus 0 times of C3 plus 1
Yes.
times of B.
Yeah, yeah.
So I will get B itself, right? So in that case, solution will always exist. Clear?
So there the scalar will be for that column, you will be using 1, right?
Yeah. So this is an
X
additional
is equals
question.
to 1, right?
Huh? So what is the solution vector? 0, 0, 0, 1. This vector.
Okay. Thank you.
Okay, so see, this system always checks whether this B lies in column space of A, where the coefficients are given by this solution vector. These coefficients are given by this X. Clear?
Yeah.
So, see, if I
Yeah, yeah.
wrote this like this, suppose A matrix, I just pressed it so that it became flat. Okay. So 0, 0, 0, 1. Now, isn't this the linear? Now, this, you know that this is the dot product. So 0 times of C1 plus 0 times of C2 plus 0 times of C3 plus 1 times of C4. Isn't this the linear combination?
Yes.
Okay. So clear. Okay. Now, third question. Let AX is equals to be a system of linear equations where A is a square matrix for, not a square matrix, rectangular matrix 3 cross 4. Okay. You have a solution vector X. Okay. B belongs to R3. Okay. Uh, See, B will always be of this dimension, whatever are these columns, because you are linearly combining these columns, right? So B will also be from R3. Okay, you should be able to see this very quickly. That my output. See, one more thing I should tell you. Suppose this is a function x is equals to fx is equals to x square. So if you put 5 in this, what will you get? 25. Yes or no?
Yeah.
Yes or no? Similarly, a
Yeah,
matrix
yeah.
is also a function in which you put a vector, here, and you will get a vector as output vector, and that output vector is always, so if this is m cross n, A is m cross n. So matrix acts as a function. So if this is a m cross n matrix, then output vector will be in Rm. Okay, that is for this input vector. Use the numbers present in this input vector. Suppose I give you 2052 and A was like 1 2 3. Okay, suppose A was 1 2 3 4 5 6 7 8 9. Then this is a function A, and I gave you this input vector 252. Then output vector would be 2 times of first column, that is 2 times of this column C1, okay, whatever this is, plus 5 times of this column, plus 2 times of last column. Okay, so you will get due to this you will get an output vector in R3. You can see that if you add these 3 columns, okay, add these 3 columns, you will get a vector in R3. Yes or no? Yes or no?
Yes.
Okay, so you will see this a lot in week 5. Okay, where every linear transformation is basically a matrix. So you will see that there are linear transformations. So you will get confused like what is linear transformation, all that. It's just a function. It's just a matrix function. Clear? Okay, so let's see this question now. Let Ax is equals to be a system of linear equation where we have given this matrix, and x is a vector, input vector, and b is a vector in R3. Obviously, you can see it will belong in R3. Which of the following statement is true? A is in row echelon form. Let's check whether it is in row echelon form or not. So first of all, first pivot. Okay, no pivot. Second pivot, third pivot. Is A in row echelon form? Yes. Because it is clear down this pivot also, this pivot also, this pivot also. Okay, so A is in row echelon form. Now X, which is an independent variable? Tell me from yesterday. Which column does not have any pivot? Second column.
Second.
So X2 will be, so see, X1, X2, X3, X4. So X2 will be, so if there is second column, then X2 will be the free variable or independent variable. Clear? After reducing the system to reduced row echelon form, so you can directly tell me the reduced row echelon form. So above this pivot, there is nothing, so no need to worry. Above this pivot, it is already 0. And above this pivot, you would have to clear. So what would be reduced row echelon form? This is always unique. So it would be 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Clear? This would be the reduced row echelon form. So after reducing the reduced row echelon form, value of x3 is dependent on value of x4 in the solution vector. So first of all, x2 is the independent variable. So when you would be rewriting the system, okay, rest all are dependent variables. So it should be dependent on x2, not x3, not x4. Okay, so this is wrong. Clear?
Oh,
Anyone, any doubt in this?
Here the vector is taken column wise, right?
What vector?
1 0 0. Well, like in the first problem, we have taken row wise, right? Here,
What row wise?
row space and column space. We
Right now we are not talking about row space or column space at all.
okay.
Okay. See, I know it gets confusing, but don't try to like confuse it right now. Okay. So this is the
Sir-
reduced row. Yeah, go on.
Sir, can we say that all dependent variables are dependent on x2?
Yeah. No. See, the thing is, it depends. You would have to rewrite the system. Like, all you can say is that what is a independent variable? Because see, if you write the system
X2.
back,
x2 was
First of all-
independent.
yeah, first of all, we don't know what the b vector is. So suppose it at the end it came like a b c. Okay, a b c was the b dash vector after conversion, right? So what you do this, right? A to a r e f, and this will become b dash. Okay, suppose this is b dash. So if you
Okay.
rewrite the system, you would write it like this. First this column. So this would be x4 is equals to, so 0 times of x1, 0 times of plus 0 times of x2 plus 0 times of x3
Yes.
plus
Yes.
1 times of x4 is equals to d. Okay.
Yeah.
yeah.
So x4 is d. Now this third. So 0 times of x1 plus 0 times of x2 plus 1 times of x3 is equals to
C.
b.
C.
B.
C.
Sorry, this is c. This is B.
C.
Okay, A, B, C. There are three
Okay.
only.
Yeah.
Then x1 is equals to A. So in this case, you can see that. So you know what your solution vector is like. So if you write x1 in place of x1, you will write A. So this is a fixed number, okay, which we don't know.
Right.
A in place
Right.
of x3, x2 would be a free variable. So this can take any value. So x2
So
what will be x3 B and x4 will be C. So these will never change, A, B, C. But x2 you can take any value in real line. So you can see that you can just tell what is a dependent variable. Sorry, independent variable. So
But x2 is equals to
for
0 now,
no, why x2 is equals to 0? X2 is an
because all,
independent
all are
variable.
zero, all are zeros in this
No,
column.
X2,
Well,
X once you see that there is no pivot in that column, second column, you will say X2 is an independent variable.
So it
Okay,
can
so
take any value.
any value. So let me write some instances. A, this will never change. So 0, this is one solution instance. Then A, 5, B, C,
yeah, any
A,
arbitrary number it can take.
22 by 7, B, C, then A, 10 lakh, B, C, then A, 0.000001 BC. So these are all solution instances. That's why we have infinite
Yeah.
solution due to the
Yeah.
presence of a
Yeah.
free independent variable. Clear?
Yeah.
Okay, so you can just tell what are the dependent variables. But see, you can see that in this case, all the dependent variables are not dependent on x2 anyway,
Yeah.
right?
Yeah.
Okay, so after reducing system to reduced row echelon form, the value of x3 is dependent on value of x4. No, this is wrong. Okay, it is not dependent on anything. If it were to be dependent, then it would have been on x2, not on x4 anyway.
Got it.
Okay.
Yeah. Thank you.
So when b is equals to 1, -2, 3, the system has infinitely many solution. Now for this you would have to check. Okay. Uh, okay. Can we get this vector? Okay. Yeah, you can get this vector. See, why can you get this vector? So see, A has three independent columns. This column, and this column. So if you see this column, and this column, so you know what will be the solution vector for B in case of B? Can you tell me directly? See, these are the basis vectors. I have told you this column, and this column. So if you see, these are the standard basis vector. So whenever standard basis vector are given, you can directly tell me the coefficients. So if B is -1, -2, 3, so this will be first, this will be -2, and this will be 3. So in that case, this will give you B vector. So in that case, you will have solution. Yes or no? Anyone having any doubt?
Not for.
Yes, so please repeat.
Okay. So see, you can see after okay, after conversion to, okay, first of all, A is already given in row echelon form. Yes or no?
Yes,
Yes
sir.
or no?
yes,
What
yes,
is the span? What is the span of columns? What is the dimension of span of columns of A? Would it be a three-dimensional subspace?
yeah, R3.
There are
Yes,
three
sir.
independent. So it R3, right? Now you know that span of these columns is R3 itself, and B belongs to which space?
R3.
R3. Yep.
R3.
R3 itself, right? So okay, wait 1 second. Yeah. Yeah. Okay. So you know that it will definitely have a solution, but I don't know whether it will have infinitely many solution or unique solution. But since you can see that there is a one free variable x2, okay, there is a one free
Yes, sir.
variable, so
Yes.
that will cause this to have infinite solutions because there is
Oh.
like a free variable. But see, if suppose this column wasn't there at all, okay, so this was a 3 cross 3 matrix, then in that case there would be unique solution. Clear?
Yes.
Sir.
But since there is a free variable, this fourth column is a free variable that is causing this to have infinite solutions.
Oh.
Clear?
Yes.
The number of no, rank of this is
Rank of A is 3.
less than the number of variables, right? Then it will
Less
be
than number of
invariable.
columns. It should be less than number of columns. So it is 3 instead of 4. Number of columns are 4 and rank is 3. Clear?
So in this
Okay, okay, okay.
reduced form itself, it is clear that it has infinitely many solutions. So
Yeah.
why E is equal to 1 minus 2? Is it a random value or
A is equals to what? Sorry?
is equal to vector given 1 minus 2, 3? The system has
Yeah.
infinitely many. That option. B
Yeah.
is a random value or
So B is the vector for which we are solving this system. Okay. We want to find x such that on multiplying x with A, I will get B. Like, see what this is. This is nothing but x square is equals to 5. This is just this. So when you know this thing, this equation is written, right? This is an equation. Okay, what is an equation? When a function is equated to a value. Suppose, okay, I'll explain. See, this is where you get confused. So suppose I give you this quadratic function. You know that this is a quadratic function, right? Fx
yes,
is equals to x square. So
yeah,
what is a function? You feed values and it gives you output. For 5 it will give you 25, for 6 it will give you 36. Okay, but when you equate a function to a value, this becomes equation.
yes,
So now for equation you want to find values of
X.
x such that it is equal to this. So you know that what is value of x? It would be plus minus 5.
yes, yeah,
Similarly, this is a matrix equation in which this will be given A, this will be given. Now you want to find value of x such that left hand side is equals to right hand side. Clear?
Okay. Yeah.
okay, 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 fine, fine.
Okay.
So we
See,
can
these are
say
your
that.
these are your basics from maths one. Huh?
So we can say that in matrix A we can have so many values that will end up in the answer B, which is 1 minus 2 and 3.
Yeah. So basically for B, I have many solutions, many such instances of x. Like in x square
Yeah.
equals to 25, I had only
Yes.
two such possible solutions, right? Plus and minus 5. In this case, I have many such x's such that on multiplying them with A, I will get B vector.
Right. Right.
And what is causing that? It is being caused by this free variable x2.
Agreed. Yeah.
Clear? So I hope it should be
Yes.
very clear now.
If
Yes,
pivots is equals to
Okay.
number of columns, then we will get unique solution.
If pivots is equals to number of columns, so yeah, that would mean that it is a square matrix, right? In that case, you will get unique solution. But it has to be a square matrix. But can you see that it is a square matrix? No, it is not. It is a rectangular
No,
matrix. 3,
rectangular
3
matrix.
cross 4. Okay. So yeah, okay. So one more like heads. I mean, just a head start. I think no, not head start. Just I don't know what. I don't remember. It's what the correct term is. Just a head. Yeah, just a heads up that in week 5 onwards you will be studying this function fx is equals to ax. Right now you have been studying equations till week 4. From week 5 onwards you will be studying this function. Okay, so you can see that left hand side of this equation is same as this. That is, you will be feeding vectors and you will be getting outputs. In that case you will be dealing with injective functions, surjective transformation, all that. Okay, so till now you have been studying matrix equations. Now you will be studying matrix function from week 5 onwards. Clear?
oh,
Okay, so when b is equals to 1 minus 2 and 3, the system has infinitely many solution. Yes. Okay, so because of this independent variable. But if this column was not there, then in that case you know that it would be unique solution. Okay,
yeah,
so this is true. Okay, now system has two dependent. And okay, what about the case when suppose this was a this column was actually same as the first column? In that case, the subspace spanned by the columns of this would be a two-dimensional subspace. Yes, in R3 it would be a 2D subspace in R3. In that case, B could lie outside that 2D subspace, and in that case there would be no solution. Yes or no?
Wait, once again.
Okay, just forget about it, like it's extra anyway. Okay, the system has two dependent and two independent variables. That is wrong because it has only one independent variable, which is x2. Okay. Now this question, b b is equals to this set is linearly independent subset of R3. Okay, that is V is independent of V2 and V3 and vice versa. Select all the linearly independent subsets of R3 from the following. So first, this is one vector and this is one vector. There is a comma. If you see clearly, there is a comma. Clear?
Mhm.
So they are asking you to check which are the linearly independent subsets of this. So first of all, okay, let's see this second option. Tell me if you are in R3, what is the maximal independent subset
Three.
cardinality you can have?
Three.
Three.
So
Three.
can this ever be a linearly independent subset?
No. No.
No.
Clear? Okay. Now you have to check for the other sets. Okay. So first of all, you should know when you are talking about only two vectors, v1 and v2. In that case, this for these two to be linearly independent, this vector should not be a linear multiple of this, that is scalar multiple of this. Okay, so you can check it now. So v1, let's suppose that this is proof by contradiction. Okay, so I am assuming that v1 minus v2 is a scalar multiple of this vector. Okay, I am assuming this. Okay, so in any step, if I encounter something which is false, then that would mean that our assumption from which we began with was false itself to begin with. Okay, so v1 minus v2 is equals to kv1 plus kv2. Okay, so now you can you have to
Excuse me,
equate.
sir.
So, yeah.
I'm not getting what are you saying properly. Can you repeat?
Okay, when are two vectors independent? When are two vectors independent? When there are just two vectors, when are they independent? When one is not linearly sorry, when one is not a scalar
Yeah.
multiple of other. Yes or no?
Yeah. Yeah. Yes.
Sir.
Okay, the girl who originally asked the question, tell me, do you know this?
Yes, sir. I know, sir.
A vector is linearly dependent on other vector if it can be expressed as a scalar multiple of the other vector. In
Yeah.
that case, they are dependent.
Yes.
But if they cannot be expressed, then those two are independent. Yes or no?
Yeah.
So what I am saying
Okay.
is, so this is proof by contradiction. So what I do is, I assume that they are actually linearly independent. So
Yeah.
v1 minus v2 will be some scalar multiple of this v1 plus v2.
Yeah.
Okay, so this I am assuming to be true. So let's start solving this. In any step, if I encounter something false, then this would mean that this was itself false. Okay, so this is I have like
When it will be
dis
false.
distributed k. So just equate k. So k from v1 is 1 and k from v2 is, in equating this to this,
Minus one.
k is minus 1. So k cannot be both, right?
Yeah.
So this is false. Okay, so this is a linearly independent subset.
Independent. Yeah.
Clear?
No, sir. Not clear.
But it's dependent. Na?
No, it's not dependent. You were not able to find scalars. It's independent. So I assume, see, suppose
So how do you get k is equals to 1 and minus 1?
it's like this. Suppose ax plus by is equals to 5x plus 6y. In that case, if these LHS and RHS are equal, you know how to equate, right? With x, whatever there is with x will be, so a will be 5 and b will be
Yes, sir.
6. Yes or no?
6.
Okay,
Yes,
that's
sir.
what I was doing there. Okay, let's see that back. So what I assumed was, yeah. So see, I assumed that v1 and this vector and this vector were actually scalar multiples. So there will exist some scalar k belongs to real, such that they will be scalar multiple of each other. So I started solving that v1 minus v2 is equals to k times of v1 plus k times of v2. Now I am just doing that equating, which I did earlier in example I told you, right? So with V1 I have 1 here. So with V1 I have K here. So K is 1. And with V2 I have K here. And with V2 I have -1 here. So K
Yeah.
cannot take two values, right? K has to be unique.
Like we can put k is equals to 1 and -1, right?
No, see, Array, uh,
May I say something? One minute. What sir is trying to do is he's not trying to uh, prove that they are independent. He's trying to have a proof by contradiction, like are they dependent? He's trying to find that because he finds that they are not dependent, so he says it is they are independent.
see, if there are two numbers, 10 and 5, okay, so you know that what will be the value of K? In K will be 2 only, right? There can be no other K, right? Such that 10 is a multiple of 5. Can there be any other K?
No, no, no. No, it's not
Can
possible.
there be any other K?
No, no. K is equals to 2.
Similarly, how can there be two Ks? So this
It can be
means that
-1.
there exists
It can be
exists
-1.
no such K. No, that is not relevant. What I'm saying, there should be only one scalar, right? How are there two scalars?
Yeah,
Right.
one
Had
scalar.
been there one scalar, then it would have been dependent
Yeah.
because there are no one scalar, so they are not dependent.
Yeah. Okay. Clear.
And sir, one thing more, how
Yeah.
they are equal. V1 minus V2 is equals to K V1 plus V2. How did you equal
Array,
them?
I assumed it to be true. That is LHS was equal to RHS. So I am just equating.
Okay.
I am following that truth. I am equating. Okay.
Okay.
Following
One
that
of them
truth, I am
will be
equating.
together.
Since I know that LHS
That
is
is
equal to RHS,
that is in the question actually, that we have to see that are they independent or not.
we have to check, right, whether they are
Yeah.
independent subsets. Okay. If you are not understanding, I will explain you like at the end. But right now, I need to move on. Okay. So these two values tells me that there is no unique like scalar K. Okay. So these two are independent. Okay. Now what about this? Let's check it again. So okay. Now for three vectors, what was the condition? If any vector, so let's pick this third vector, can be expressed as linear combination of the other two vectors. So there are two vectors, right? So let's say there is a scalar A and V1 plus V2. Okay, so we are again assuming that they are linearly dependent. So there must be some scalars A and B. Okay, so for second vector this, such that this third vector is linear combination of the other two vectors. We are assuming that this is true. So again, we will just follow this. So this will become okay, A V1. I'm directly writing it. Okay, just expand this A V1 plus A V2 plus B V1 minus B V2. So this would become A times of, sorry, A plus B times of V1 plus A minus B times of V2, and there is no V3. Okay. Okay. So now you just need to equate with V1. I have 1 here, so I will equate A plus B to be 1. With V2, I have 1 here, so A minus B is 1. Now I just need to solve these two equations to find A and B value. So if I add them, what will I get? 2A is equals to 2, right? B will cancel with this, so A is equals to 1. What will be B value? B value will be 0. Okay. So I was indeed able to find two unique scalars. So this is a dependent set. Okay.
Yeah.
This is a dependent set. Clear?
So
That
sir,
is,
if there were same variable and different values, then it is independent.
No,
And have different variable, different values. Then it is dependent.
Okay, suppose, uh, okay, suppose I would have to build okay, suppose there was a V3 here. No. Suppose there was two V3 here. So in that case, it would become 2AV3. Yes or no?
Yeah.
There would be a 2AV3. In that case, 2A would be 1. Yes or no? But from
Yes,
these two
sir.
equations, I will get A as 1. But here I am getting A as half. In that case, it would have been contradiction. Because A cannot be two values at once, right?
Yeah.
Okay, sir. Got it.
Okay. Okay. So this option is wrong. What about last option? Let's again check, because again there are three vectors. We will use the same method. So v1, let's say v1 is scalar multiple of v1 plus v2 plus b times of v1 minus v2. Okay. So let's see what will be v1, a plus b, and what will be v2,
A minus
a minus b. Now in this case, a plus b is,
1.
with v1 it is 1, and with a minus b it is 0,
0.
because there is no v2. Okay. So in this case, a plus b is equals to half, a minus b is equals to 0. So you add them, you will get a as half and b as 0. Sorry, b also as half.
Half.
Minus half, sorry. No.
Half.
Okay. Yeah, b also you will get half. Okay. So in that case, there exists some unique scalars. Okay.
Yeah.
So this is also not an independent set. Clear?
Yeah.
So only first was linearly independent. Clear? Now this question, A is a square matrix of order 3. Select all subspaces of R3 from the options given below. Okay. Now, see, this is such that, okay, such that AB is equals to 0. Clear? So, okay, just wait 1 second. Select all subspaces. Okay. So, I have no information about A. I just know that A is a square matrix of order 3 cross 3. Clear? So, I don't know anything about the columns of it. Yes or no? Yes or no? So, AB is equals to 0. I know at least one solution, right? This is a homogeneous system. Yes or no?
Yeah.
Yes.
So, I know there is at least one solution where V is equals to 0, 0, 0. Yes or no?
Yeah.
But I don't have any information about this. So there can be more such V's, but I am at least sure that there is at least one V. Yes or no? This is the only information that I can deduce from this. Yes or no? Because there is no information about A. But I know for A, all my V's such that AV is equals to 0, I know there is at least one V, which is the 0 vector itself. Yes or no?
Yes.
So is 0 vector a valid subspace of R3?
No.
What are the subspaces of R3?
3-dimensional.
No. What are the subspaces of R3? First is the 0 vector itself. Second is a line through origin. Third is a plane through origin. And fourth is a R3 itself. So 0 is actually a valid subspace, right? So this set S here is, I don't know what it is actually is, but I know at least there is one, like in worst case, it would be just this. In case A is not an invertible matrix, okay, in case A is not an invertible matrix, there will be more elements. But if it is an invertible matrix, there will be only one element, right? Yes or no?
Yes.
See, I am only sure about whether there is, I am sure that there is at least 0. So, this is actually a subspace. Clear? What about this V? Now I don't know any information about A. Okay. So I cannot say that it is a subspace. Clear?
Clear.
Why can I not say that? Just tell me.
Because
Because it's not a homogeneous.
homogeneous. Because see, if A was an invertible matrix, okay, if A was invertible, and there is some vector here 1, 2, 3. If A is invertible, then I know that V will be unique, yes or no?
Yes.
Unique, yes or no? That is, it will be just some point, yes or no? It will be some point in R3, yes or no? It will be some single point in R3, yes
Mm.
or no? Now, is that point the zero vector? Because the only subspace which is a point, see, this line is not a point. This plane is not a point, but a set of points. This is also a set of points. This is also a set of points, and this is a set of points. Only zero subspace is just one single set of points. Yes or no? Which is also a subspace.
Yes.
So tell me, will that unique solution be zero vector? No, because if you just multiply
No.
a with 0, you will get 0 itself, not 1, 2, 3. So that cannot be 0. Yes or no? So it cannot be a subspace in that case. Yes or
Okay.
no? But see, the thing is, we don't have any information. So in the so when we are talking about AV is equals to 3, right? It should be true across all cases. So it is failing across one case, okay, which is this case where it is a unique solution, which is not the zero vector. In that case, it is not a subspace. Clear? But if it was, suppose if it was a non-invertible matrix, that is one of the column was actually zero, I mean linearly independent on the other columns, then in that case, if B lies in the column space of this, then in that case it would be a subspace. But anyway, don't worry about this. Okay, like it's very complex. Like uh, if you are very well versed with what is happening, like you can see the overall big picture, then you can answer these questions like in matter of 5 seconds, 2 seconds. Okay, so this is not a correct option. Clear? Clear?
Yes.
What about this? uh Obviously, like this is a point in R2. How can this be a subspace of R3? Okay, so this is wrong. Clear? What about this? What about this? This is actually nothing but your xy plane. X comma y comma 0. That coordinate is always 0.
Oh,
X
yeah.
and y,
That's well
take
played.
any real
Yeah.
number. So this is the xy plane in R3. So this is a
Mm.
subspace. Clear?
Yeah. Yeah.
Okay, now this question. Okay. AI. So A is a 5 cross 5 matrix such that Aij is equals to Aij plus Aji is equals to 0. That is, it is written basically Aij is equals to minus A of Ji. Clear? Now, can you tell me what is the characteristic matrix for this? Is it the skew symmetric matrix?
Is it symmetric? Yeah.
Yes, sir.
Like 1 second. Aij. Uh, okay, no, it is not necessarily skew symmetric matrix. Yeah, it is skew symmetric matrix because see, uh, so let's start writing. For first element, for first row, that is I. So I see, I always, whenever this type of notation is given, right? If you are having confusion, just note like this: a matrix, draw a matrix, and do this. Ij.
Oh, yeah.
I
Yeah.
represents the row. I will iterate like this. Okay, J will iterate like this over the
Yeah.
columns. Clear?
Yeah.
So when you want to write any element, just go to that corresponding row and column and just use this and you will write it. Okay, so let's write it. So suppose it is a 5 cross 5 matrix, right?
Yeah.
So first element, what would it be? So it would be A11, right?
Yeah. One.
Now, so A11 plus A11. Okay, so A11 plus A11 is equals to 0. This implies that A11 itself must be 0. Yes or no?
Yeah.
So it will be 0. Similarly for A22 also. A33 also, A44 also, and A55 also. Clear? So
Yeah.
it has all elements along the diagonal 0. Now what about A21? So sorry, A12. So that is first row, second column. Here, this element. What would
Yeah.
it be? It would be so
Should be minus
A12 plus
minus A21.
A21 is equals to 0. That is A12 is equals to minus of
Minus
A22.
A21.
Okay, now I can take any value for A12. So if I take A, then I already know that
Minus A.
A21 should be minus A. Yes or no? This position.
Yeah.
So this is C. This is the first row, which
Second
column is
column.
it? Second column.
Second column.
So A12 is minus of A21. So if I take A12 as A, so let's do not confuse you. Let's take it as A12, just pick any random character. So let's say P. This would be minus P.
Minus P.
That is A21 is minus of A12. So it would be minus P. Similarly for this also, A13. A13 plus A31 is equals to 0. This implies A13 is equals to minus of A31.
A31.
Now let's take Q for A13. So Q, this would be minus Q. Similarly, now R, minus R. PQR S, minus S. Sorry.
No, here. First row. First
Yeah.
column.
Minus S. Okay.
Yeah.
So it is going like this. Okay. So similarly, you can write all the elements. P, Q, R, S, T, U, V, W, X, Y. So minus T, then minus T, then minus U, then minus V, then minus W,
W
minus X, and minus Y. Okay. Yeah. So somewhat disoriented, but I hope you are getting this. So this is column, this is column, this is column, this is column. Okay. So one direct result which I should tell you is, if you ever have a skew symmetric matrix, just check P minus P, Q minus Q, T minus T, R minus T minus R, S minus S, V minus V, U minus U, W minus W, X minus W. So determinant of a skew symmetric matrix, is it always 0? Okay. If okay, see, the thing is, what is a skew symmetric matrix? If transpose of a matrix is equal to the negative of the matrix itself, then it is a skew symmetric matrix. Clear?
Yeah.
Now you can directly do it if you take transpose on both sides. Determinant on both sides. Now tell me, can I write it like this? So I know determinant of A transpose is determinant of A itself. Yes or no?
Yeah, it is. It is.
Can I write this as minus 1 of determinant of A? Just tell me. Can I write? Is this a correct step?
Yes.
So this tells me that if I take it right, LHS to 2 times of determinant of A, it is 0. This means that determinant of A should be 0. Anyone? Is this correct? Is this correct?
Yes.
Yes. So.
Anyone who would like to answer differently? Is this correct? Anyone is there?
Yeah, I thought of an edge case here. गिवन द कंडीशन, अगर अपने पास एक जीरो मैट्रिक्स है तो वो भी उस पूरी कंडीशन को सेटिस्फाई करेगा, और जीरो मैट्रिक्स का डिटरमिनेंट भी जीरो होता है, तो वी कैन डायरेक्टली राइट आंसर एज जीरो.
No, see, you are trying to generalize it because that is a unique matrix. Okay.
Okay.
See, the thing is, what is a wrong step here is this step, because you didn't pay attention. This is a wrong step. Why is it a wrong step? I mean, in this case it is correct, but it is wrong. Huh?
It is not zero.
No, determinant will be 0. That is correct. Answer is 0. But the thing is, why is it not correct here? I mean, why this step is not correct in general? Because if you remember, what was the result? So if you have a matrix A, okay, and you multiply it with some scalar, then what is the determinant of Ka?
K determinant of A.
Is it?
Yeah.
K cube determinant of A.
K into determinant.
In general, it is K to the power n determinant of A.
Yeah, K to the power n determinant of A.
Yeah.
So
yeah.
This minus 1 would only have been possible if it was an odd power, like 3.
Yes.
Or minus 1 to the power 5. In that case, this step would have been correct. but like I mean, luckily it is the case that it is like
3 cross 3.
yeah, it is 5. So actually it is minus 1 raised to the power 5. So it will be minus 1 and then you will transfer it, and this is actually true. But the thing is, if it was a if it was a even number, then in that case this step would have become minus 1 to the power 4. Suppose it was a 4 cross 4 matrix, determinant of A. Then you cannot tell anything from this step, right? Determinant of A is equals to determinant of A. This is a trivial equation saying like 5 is equals to 5. So you cannot determine anything. So determinant of a odd order skew symmetric matrix is always 0. Okay, so this is the result.
Oh,
Skew symmetric matrix is always 0. But what about even order skew symmetric matrix? Then you cannot tell anything. Clear? Yes or no?
yes.
Okay.
Yes, sir.
Now determinant of A is minus 2. Determinant of A transpose A they are asking. So you know that this is the property, right? Determinant of AB, given that A and B are both invertible. So see, first of all, you should be like able to read maths language. Don't directly like jump into like, okay, I know that determinant of A is minus 2. Determinant of A transpose is the same as determinant of A. In that case, it would be 4. So that is correct. I mean, in a sense, it is correct, but you should like every statement has some like information which it is giving. So if I'm telling you that determinant of A is uh, determinant of
Minus 2.
A is minus 2, this tells you that A is invertible.
Yeah.
Okay, A is invertible. This implies that, okay, is this property determinant of AB is equals to determinant of A into determinant of B always true?
Yes.
No, it is not always true. It is only true.
It is only true when determinants of A
Wait.
and both. Yes, yes.
Order are
Wait.
same.
No. Wait. I think it is always true. Yeah. Determinant of
If both
A,
are
B.
invertible, right?
No. Yeah.
If
See,
both
it
are
is
invertible.
it is not always true, because A could be a
Hello.
square matrix and B could be a
Yeah,
rectangular
if
matrix.
order is same, then it is.
Yeah. Then it is same. Okay. So you should like read the fine print. Most of the time the condition is given. So it is only possible in case of both A and B being square matrices. Clear? So yeah. So if A is invertible, then A transpose will also be invertible. So you
Invertible.
can anyway directly write this like this. See, why I'm telling you this is, see, if A was a, like suppose A was a 2 cross 3 matrix, 2, 3, 4, 5, 6, 7, and what would be A transpose? 2, 3, 4, 5, 6, 7. In this case, this is a 2 cross 3. This is a 3 cross 2. So in this
Yeah.
case, determinant of A transpose A, you won't be able to write like determinant of A into determinant of B, because determinant of A into determinant of A transpose, because
There is no
both are not
transfer.
like square matrices.
Yeah.
Okay,
Determinant is only for
square matrices.
square matrices, right? So
Okay.
in that case only we can.
Yeah. Okay, because the thing is, if suppose A is a matrix, rectangular matrix, okay, A is a rectangular matrix like this. In this case, determinant of A transpose A will actually exist, which is not 0. Okay, so I'm just telling you like that, but don't worry. I mean that level of questions won't be asked. Okay,
Then
so
how could we
determinant of
get the answer?
sorry.
How could we get the answer of it? Like we haven't given any order of it.
See, it depends on A matrix. If A is a full rank matrix, okay, full rank matrix, then determinant of A transpose A will not be 0. That is, A transpose A will be invertible. Okay, so this is determinant of A whole square. So this is minus 2 whole square. This is 4. Okay, so this is answer is 4.
Sir,
Okay,
excuse me, sir.
yeah.
So in previous question, it's previous. Yeah, in this question is, yeah, this is the same question. all the diagonal elements are 0, then we can say that the determinant is 0.
No. You cannot tell that. How? You can only tell if all the elements here were. So see, there exist skew symmetric matrices. So suppose this 0, 0, 1, -1. In this case, what is the determinant? It is -1. So it is +1. Yes or no? Is it 0? No. And this is a even order skew symmetric matrix. So you can see determinant is actually 1.
Yes, sir.
Clear? You can only tell if these elements were also 0. If it is a triangular matrix, then you can directly tell determinant from the diagonal elements. If it is any triangular matrix,
Lower
whether it be
triangular.
upper triangular, lower triangular, or both, that is a diagonal matrix. You can then tell.
Thank you.
Clear? Okay, let A be this matrix. Now, this is an equation given. So, whenever an equation is given, you have to find the unknowns. Note that I is the identity matrix, 0 is the 0 matrix. Okay, so you have to just find value of alpha and beta. So, what you can do is directly calculate A square. So, 2 minus 1, 4, 3. 2 minus 1, 4, 3. So, this will be okay, this will be
4 plus 4,
0,
8.
0, okay, 0, then -2, -2, -3, -5, then 8 plus 12, 20. Okay, so this into this, you can do matrix multiplication at least. -4 plus 9, that will be -4 plus 9, that will be 5. So this is the A square matrix. Now just place it in this equation. So 0 minus 5, A square is this, right? 25 minus alpha times of A is 2 minus 1, 4, 3 plus beta times of identity matrix is equals to the 0 matrix. Just equate it. You will get -2 alpha plus beta, then -5 minus alpha, -5 plus alpha, sorry. I'm adding these matrices, okay? That's how this matrix is coming. So 20 minus 4 alpha. Okay, then you have 5 minus 3 alpha
plus beta.
Now just equate these two matrices. So -2 alpha plus beta is equals to 0. So beta is equals to 2 alpha from first. Then alpha is equals to 5. Then beta is equals to 10. I can just stop here. So what is alpha? Alpha is 5. Beta is 2. Beta is 10, sorry.
Yeah.
Now this question. Find the dimension of the following vector spaces. The usual rules of vector addition and scalar multiplication for the vector spaces in each option. In each of the options. So I will tell you one thing. Whenever these types of sets are given, okay, and this some equation is given. Okay. See, first of all, what you can do is you can I will show you as like A, B, C plus D plus E is equals to 0. Now, can I write this equation in form of some matrices? I can write it like this: 1, 1, 1, 1, 1. Yeah, sure. A, B, C, D, E. Okay, is equals to 0. Is this true?
Yeah.
Now tell me, is this a matrix? Is this a matrix? Now tell me how many pivots are there? Only one, since there is only one row.
Yeah.
Okay. So
You can write it like this.
how many times? How much time? After it, okay. Yeah, hello. Yeah. So tell me how many pivots are there?
One.
And this is a 1 cross 5 matrix.
Yeah.
Yes or no?
Yes.
This is a 5 matrix. Oh, sorry, this is a 1 cross 5 matrix. So how many? How many? So you have to tell the dimension of this set A, B, C, D, E. Yes or no?
One.
So see what you have to do to tell the dimension of this set. Okay, this set. You have to just count the number of free columns, number of columns without pivot. So is this a column without pivot? 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 So there are 4 such columns. Yes or no?
Yes.
So there are 4 independent variables in this. A,
Yeah,
C,
yeah.
D, and E.
Yeah.
Okay, so dimension of this is 4. Clear? Anyone for which like this went above their head?
How you can write it like 1, 1, 1 for A
See.
matrix?
1, 1, 1, 1, 1. So I just
Okay,
tried
coefficient
to write this.
taken as 1.
Okay, then see, then another method which is like full, like you can always like do this. Okay, so this is one method. I mean, you if you are like proficient, then you can come up with this. But like if you are not, then what you need to do is right now there is only one equation given. Okay, suppose if there was one more equation given, 2a plus 5b plus c is equals to 0. Then what you need to do is you need to solve these two. Okay, just forget about it right now. It would be too much. Okay,
So
so
what is
right
the
now there is
rank
only.
for this question?
So rank is 1. You know, right? Rank of a matrix is less than minimum of m cross n. So what is the order of this matrix? 1, 5. So
1.
m is 1 and n is 5. Okay, so 1, 5. Now you can see that there is one pivot, so it will be 1 only. Okay, so rank will always be less than 1. So see, this tells you that rank will be less than equal to 1. This does not tell you whether rank is 1. You have to see the matrix itself. So suppose if this was a matrix 0, 0, 0, 0, 0. So this is also a 1 cross 5 matrix. Its rank, and from this I will just deduce that rank is less than equal to 1. Okay,
Rank is
but from
equal to
seeing the
dependent
actual,
column.
sorry,
Rank is equal to the dependent column of matrix.
yeah. So how many dependent columns are in this?
One. When we generalize it.
Okay, first of all, always see whether how many independent columns are there. So is there a pivot here? Is there a pivot here? Is there a pivot
No.
here? Is there a pivot here? Is there a pivot? No,
No.
no pivots, right? So all are free variables. So there is no dependent columns. So what is the rank? Rank is 0. Clear?
Dimension.
Yeah.
It depends on number of variables.
What depends on number of variables?
Rank will be depend on number of variables.
No. See, rank is of a matrix. Rank is of a matrix. It is not dependent on number of variables.
Oh, number of pivots. Number of pivots.
Yeah, that is true. Okay, so see, like this, you are saying this. So there are 3 variables, x, y, z. So is the rank 3? No, rank is just 1.
1.
Rank is dependent
Yeah,
on the matrix itself, not the variables.
yeah, not the free variables.
So
Okay.
the dimension for this
Okay.
question will be
So dimension of the matrix is 0. Sorry, 1 in this case. But they are not asking you dimension of this. They are not asking you dimension of this matrix. They are asking you dimension of this solution vector. So you have to calculate how many free variables are there. Okay. So another way would have been rank plus nullity. So see, rank is dimension of the matrix. Nullity is dimension of this solution vector.
Independent. Yeah.
So the rank is dimension of the matrix. Nullity is dimension of this solution vector. Okay. Also note that there is a 0 here. Okay. Nullity will always be calculated when there is 0 vector here, not any other random vector. Okay. So nullity is actually dimension of this. So you can directly tell from this. So if you see rank here is 1, and you know that this is equal to the number of columns, so 5. So nullity will be
4.
4.
Here
Okay.
the dimension,
Now,
this is a vector space, so we are looking for dimension, right?
yeah, so see, the thing is, both of these, when you have been given ax is equals to 0, right? This is also a vector space. This is known as null space. So solution set for this equation,
Okay.
solution set for this equation where there is a 0 here, this x is actually called as null space. So this is also a subspace. Okay, that's why we are asking the dimension of this.
That is 4 here, right?
Yeah, it is 4. Okay, so let's see another way. If you are like not comfortable with this, then there is another. So what do we do? So what do we do? Whatever equations are given here, you pick them up and you express one of the variables as combination of other variables. So this would be minus e, minus b, minus c, minus d. Yes or no? From
Yes.
this equation.
Yes.
Now what you need to do is you need to write this general vector down. So I know there's a, b, c, d, and e. In place of e, I can write this. Minus a, minus b, minus c, minus d. Now what you need to do, this is the general vector, okay? Now what you need to do is you need to see how many variables are there. 1, 2, 3, 4, okay? There are only 4 unique variables. So here there are a, b, c, d, we have already counted. So what you need to do is, you need to pick out a, and in place of a, place 1. So this would become minus 1. And rest all the variables 0. So in place of b, c, d, 0, 0, 0. So 0, 0, 0. Then there is 1 minus a here. So this will become minus, rest all are 0, so 0. Plus b times of same thing. Now place a 0, 0, minus 1, 0, 0. And there is a minus b here. So this will become minus 1. Plus c, 0, 0, minus 1, 0, minus 1. Plus d, 0, 0, 0, 0, minus 1, minus 1. So, okay, so you, yeah, just count the number of vectors. So these are 4. So you can tell that it is 4. Also, these are the basis vector for this space. If they asked you, what is the basis for this set? Then these, just pick these vectors. These are the basis. Clear? Basis vectors. So this is a basis set. Clear?
Yeah, clear.
Okay. Now I want you to apply this same this thing here. So they are asking you what is the dimension of this. So how many free variables are there? They have directly given you the, see here we had to write the general element after removing this equation which was given here. Now they have directly given you the general element. So 0 c, 0 a plus b. So what you have to do is you have to count how many letters you can see, a, b, c. Okay, 3, right? So this should tell you that this is already 3. Okay. So okay, see here you couldn't say that, okay, I can see 5, 1, 2, 3, 4, 5. No, because there was an equation given, so you can express one in place of others. So then in that case, you, in the general element, after replacing that element e with minus a, minus b, minus c, minus d, you can see only 4, 1, 2, 3, 4. So it is 4 here. Clear? So now how can I write this? A, in place of a place 1, rest all 0, 0, 0, 0, 0, and there is a 1 here, so 1. Plus b. So plus b, what would it be? 0, 1, 0, 0, 0, 1, plus c, 0, 0, 0, 1, 0, 0. So okay, so you can see 3 matrices. So these are the basis matrices, basis set. These matrices. And what is the
10
dimension?
10 of the matrix.
Dimension is 3. Clear?
Sir, rank nullity theorem. Sir,
From
These
rank
all are
nullity.
span of the matrix.
See,
yes, sir.
rank nullity theorem. Okay. See, first of all, dimension is 3. See, the thing is, this is, so see, this is a subspace of, what, how do we write matrices? R3 cross 3, right? This is a subspace of R3 cross 3. That is, it is a subset of 3 cross 3 matrices. Yes or no? Sorry, 2 cross 3 matrices. Yes or no?
Yes,
It
sir.
is a subset of 2 cross 3 matrices. Yes or no?
Yes, sir.
So, dimension of a matrix space of 2 cross 3 matrices is 6. So, in that case, you can say that null space will be 3 because dimension is 3, right? So, in that case, null space of this set will be 3. Rank nullity theorem you can apply like that. Okay. See, generally what they do is they can express matrices also as okay, don't get into that, way too complex
Yeah,
for
there
this.
in the third set, it should be 1 in the last, right? 0, 0, 0. C into 0, 0, 1, 1, 0, 0. You have it should be A plus
So
B.
there is no C here, right? No C here, so that's why only 1 here.
Yeah, A plus B. There would
Clear?
Yes,
why
sir.
the last column it is 0.
In which matrix?
Third one, C here, last one. Basis
Okay,
the
so
C.
okay, just tell me where all C is present in the general matrix. Only here. So rest all elements are anyway 0, so that's why all 0. But here in this case, see, A was present here as well as here. So when I was placing A as 1, I was placing all the other variables as 0. So A1, 0, 0, 0, 0, 1, because there is an A here.
Okay, okay.
B1, 0,
Yeah.
0, 0, 0, and there is a B here also, so 1. Okay.
Okay, fine.
Okay, so these are the basis matrices. Clear? There most probably will be a question on matrix vector spaces. Okay, so this is also a vector space. I told you yesterday that it is just a set of objects. It need not be just vectors. It can be matrices as well. Okay. Uh, okay, now they are asking you what is the dimension of this subspace. Since you can see the word span, what you can do is you can just place them in this matrix, and you can just like apply a row echelon form, or you can directly see if you subtract this matrix, this row from this row, I will get this third vector. Yes or no? Just do it.
Yes, sir.
Are you?
Yeah.
Yes. So this is actually a dependent row. So dimension of this is how many independent rows are there? 1, 2.
2.
Okay. One more thing, if you see a 0 here and a 1 here, then obviously this tells you that they are independent. These two are independent, because see, you could have asked me like, how are you sure that, okay, fine, third is dependent on these two, but how can you be sure that these two are independent? You can directly see that there is a 0 here and there is a 1 here. No matter how much you scale any vector, this vector, you will never get a 1 here, right? Because there is a 0 here. Yes or no?
Scalar is 1/2, right?
No, I am saying, are you ever able to get 2, 1, 0 vector by scaling this second row vector? Can you ever, like,
No.
whatever because there are 0 here, right? So this tells you directly that these two are independent vectors. So dimension of this is 2. Clear?
Third row is the sum
Clear.
of first two rows,
See,
right?
what I'm saying is 1, 0, 0, and there is this vector 0, 1. Now can you ever scale this second vector to get this vector?
No.
No.
That is what I'm telling you, right? That if you see 0 here and a non-zero quantity here, you cannot ever scale any vector to get the other vector. So that's why these rest of the two are independent. Okay.
Sir,
We
once
cannot
again, what did you?
we cannot scale third row
Third,
from first
what?
row.
Sir, once again, what did you say?
Okay, forget about it. Just apply a row echelon form. Okay.
No. The concept you said. Please repeat again.
See, when we are talking about two vectors, right? Suppose this is 1, 1, 0, and this is 0, 1, 1. Now you can see there are two places. Like this is 0, this is 1. So I cannot ever scale this vector by any scalar. This can never be equal to 1, right? Because 0 will just eat up my scalar. It will never become 1. Clear? So they can never be dependent. Are you getting this? Two vectors are dependent when one can be expressed as a scalar of the other vector.
Yes, sir.
So can you ever like scale this vector to get this vector? Never, because 0 will eat up that. So I'm just saying that at a glance, if you see like this combination 0 and the other vector has 1 here, non-zero quantity here, then you can directly tell the two vectors are independent. Clear? Clear?
Yes, sir.
Similarly, see, this vector and this vector are also independent. This vector and this vector are
Yeah,
independent.
that's
But
why
when we
I'm
talk about three vectors, then we have to check whether one vector can be expressed as linear combination of the other vectors. V1, V2, V3. Okay. So this you should remember. Okay. Okay, now this 2024, we are done with one quiz. Clear? So how are you like doing like are you able to understand whatever I'm explaining till now, or is it difficult for you?
No, sir, we are understanding.
Okay. Now anyone wants to tell me how to do this question?
Rearrange the rows and determine we can find accordingly. When we rearrange, each time when you rearrange, -1 +1 like that.
Yeah, very good. Okay. So see, when you see a 5 x 5 matrix, don't directly jump onto expanding because it is almost like impossible for a guy to do this. Okay. Okay. I think complexity is somewhat of O n cube. So like 125 operations you would have to do something. Okay, so you won't be able to do it. So what you have to do is you have to see some structure in this matrix. If you see this is just an identity matrix of 5 cross 5 in which rows are rearranged. Yes or no? Like exchanged. So this hints you that you have to use the exchange like effect of exchanges of row on determinant property. Yes or no?
yes.
So let's write the 5 cross 5 identity matrix. Okay. Now, okay, see here. You have a 1 here. So this means that this row must have come here. So right now I know that determinant of this matrix is 1. Yes or no? Right now in this state it is 1. Yes or no?
Yes.
Now if I exchange row 1 with row 2, in this case it will become 0, 1, 0, 0, 0, 1, 0, 0, 0, 0. 0 0 1 0 0 0 0 0 1 0 0 0 0 0 1. Okay. Now what is the determinant? I know I have exchanged this these two rows. It is right now -1. Yes or no?
Negative, yeah. Yeah, yeah. If we
Now
switch two
okay.
rows, then
Now my first row is same. Good. Now let's see what I want in this second row. In this second row, I want a 1 here. So I switch these two rows? Yes or no? I want a 1 here, right? According to this matrix. So to
Yes.
bring a 1 here, I would have to switch these two rows. So in this case, 0 1 0 0 0 0 0 0 1 0 0 0 1 0 0 1 0 0 0 0 0 0 0 0 1. Okay. So first two rows I have made similar to this example. Now what about this? I want a 1 here, but my 1 is here. So can I switch these two rows? Okay, what is the determinant right now? It is again 1. Yes or no? Now I need to switch these two rows to bring a 1 here. So it would become 0 1 0 0 0 0 0 0 1 0 1 0 0 0 0 0 0 1 0 0 0 0 0 0 1. Now is my matrix same as this matrix? Yes, it is. Yes or no? So what has the determinant become now? It has become -1 because I did one more exchange, right? So what is the determinant? It is -1. Clear? Yes or no?
Yes, sir.
Yes, sir.
Okay. What about this question? So you know they have given you determinant of the submatrix, which is 2 of this submatrix. So just try to see this is a 4 cross 4 matrix. So you have to just be clever. You have to see on expanding along which row or which column will you get this submatrix. So you can see that
third
this row
third
has
column.
0 0 0. So if you expand along third row, okay, not third column. If you start expanding along third column, then you won't get answer. So you have to see fourth column, sorry. So if you expand it along this, then you will eliminate this row, and what will you get? So first of all, you should write So in a 3 cross 3 matrix, the sign is this: plus minus plus minus plus minus plus minus plus. But in a 4 cross 4 matrix, you have to write plus minus plus minus minus plus minus plus plus minus plus minus minus plus minus plus. So according to this element, so minus times of what is the element here? Minus 5. Minus 5. Okay. And on eliminating this row and this column, you will get this submatrix A, B, C, D, E, F, C, F, which is given here. So determinant of this submatrix is 2. So what is the answer? 10. Clear? Clear? Yes or no?
Yeah.
Yes.
Okay. Okay. Now this question. So this is checking whether V is a subspace or not. Okay. So see, the thing is they can define addition operation and multiplication operation as they wish. So to check whether, so they are asking you closure, whether it is closed under these two operations or not. Whether it is a subspace or not, it does not matter, because see, first of all, you can directly tell that this is a not subspace. This is not a subspace. Okay, where does this vector belong to? Is it in R3? Yes or no? Yes or no?
Yes.
Is this vector in R3? Now you know that
R2
any R3 it is.
Okay.
There are 3. This is a 3 tuple, right?
Yes,
There are
yes.
1, 2, 3. So one thing you should always first check you should always do whenever it is asked whether it is subspace or not. First of all, it is not asked here whether it is a subspace or not. So what I'm saying is, whether to check, to check whether a given set is subspace or not, always try to always try to find whether the zero vector from the parent subspace belongs in that or not, because you know that in R3 all the subspace always contain the zero vector origin. Yes or no?
Yes.
So you should always check. First check should always be that if it is there. So because see, the thing is, suppose you are in R3, suppose you are in R2, you know that all the subspaces would be zero vector or a line through the origin or R2 itself. Yes or no?
Yes.
Okay. So but if I have given you a set which is just the first quadrant, then it actually has the zero vector, but you know that this is not a subspace. Yes or no? You know that this first quadrant is not a subspace. Why? Why is it not a subspace? Because suppose if you take 1 1 here, 1 1. Now if you multiply this 1, scale this 1 1 with minus 1, where will you get the vector? Here, which is not inside this set. Yes or no?
Yes.
Sorry,
Yes,
you
sir.
will get the vector here, minus 1 1, which is not inside this set. So you can see that on scaling, I did not get a vector which was inside the original set. So can you see the closure property now? What does closure means? So you are getting a vector outside the original set. So this is not closed under scalar multiplication. Clear? This first quadrant. So first thing you should always check is whether zero vector, that is the origin vector, belongs in it or not. If it belongs, then you are not sure whether it is actually a subspace or not, because you can see this first quadrant, zero actually belongs in it, but it is still not a subspace. Yes or no? But first thing you should check, because if it is not there, then you will know that for sure it is not a subspace. But if it is there, you don't know. You have to check it. Clear? Yes or no?
Yes, yes.
Okay. Fine. So let's check this. So first of all, you can directly tell that the 0 0 0 0 vector does not belong in here. Yes or no? Because there is a 5 here.
Yes.
Okay. So 0 0 0 does not belong here. So this is not a subspace, that is for sure. But it can still be closed under multiplication and addition. Okay. They have defined. So for checking that, you have to use their definition. You have to check their definition, because see, 2 points from this set x1 y1 5 plus x2 y2 5 plus, giving you x1 plus x2 y1 plus y2 and 5. Properly it should be 10, right? If you add normally, but they have defined this addition operation for you, so you have to use their operation. Clear?
Yes.
Okay, don't have to use your own brain here. Okay, I mean, you have to use your brain, but don't apply the uh, operations you know beforehand. So use their operations. So see, so how do you have to do these question is, you have to take two vectors v1 v2 of this form only from this original set. So suppose let's take pq5, suppose v1 is pq5 and v2 is rs 5. Okay, okay, p, q, r, s all belongs to real number. Now when you add them, you will get p plus q, r plus s, sorry, p plus r, q plus s from this operation. See, x1 plus x2, so p plus r, q plus s, so y1 plus y2, q plus s, and 5 plus 5 is nothing but 5 only. Now you know that p and q are real numbers, so this p plus r also will be a real number, right? So I can replace it as x, suppose p dash, and q plus s will also be a real number, so I can replace it as q dash. So this is a real number, this is a real number, and this is 5. So you can check that this is satisfying this, right? All these two coordinates being real number, real number, real number, and 5, 5. Okay, so it is closed under addition. Clear?
Yes.
I am getting same element. So this is closed under addition. What about scalar multiplication? We have to check that using their definition. So what you have to do is, for scalar multiplication, you need to pick a one arbitrary element. So let's pick pq5. Okay, pq5 from this set. pq5. Now let's take a scalar k. Okay, from this. So see, here they have taken. You can take c also. C. Okay, so c. So according following their definition, cxy5 will give you cxcy5. Okay, so this will give you cp, cq, and 5. Yes or no? So p is the real number, c is a real number. So again, this is again a real number. This is again a real number. Yes or no?
Yes.
This is 5. Now this satisfies again this uh, condition. X is real number, y is real number, and 5. So real 5. Clear? So it is also closed under scalar multiplication. Yes or no?
Yes.
Yes. Yes. Okay. Now you have to choose. So this is a multi-part question. So V has no zero element with respect to given addition. Is it true? V has no zero element with respect to given addition.
It's false.
It's
Is it true or false?
true.
It's
Why?
false.
It's true.
005 is the zero
See,
element, I guess.
first of all, do not assume that this zero element will be the
It's true,
0,
sir.
0, 0 vector. It will be characteristic of the given set. So you have to check. So what you have to do is, you will assume that suppose z is a zero vector. Okay, z vector is zero vector which is present in this set. So what you have to do is, you have to take a general element x, y, 5. Okay, now I know that this zero element should be such that on adding any vector from this set, they should give this vector only, x, y, 5. Okay, so z, so you will send this that side, so you will get x, y, 5 minus x, y, 5. Now this is subtraction. Subtraction is also addition only, right? So you can write this z as x, y, 5 plus minus x. Okay, so first you have to do, this is -1, right? -1. This is -1. Yes or no? This is plus of -1. Yes or no? This is actually plus of -1. Can I write it like this? Yes or no? Hello.
Yes, yes.
Okay, now you have to do first scalar multiplication. Don't just do this. Minus y minus 5. Don't do this because this is wrong. Yes or no? You have to follow this multiplication definition. Clear? So this won't be -5. This would be 5. Yes or no? This would be 5. Getting this? You have to follow this scalar multiplication. Because see, the thing is, they have defined the operations. You have to follow these operations. Like suppose you stay in my house, and for you to stay in my house, I say that you 5 plus 5 is equals to 20. Okay, so you have to believe that. That is the gospel truth of my house. Okay, if you don't believe that, you can get out. Getting this? So they have defined these operations for this set. So you have to follow these. You don't have to apply your like normal operations which you follow in a R3 Rn. Clear? Getting this? So this is the catch here. Yes or no? So -1 on being scaling this vector will give you -x, -y, and 5, not -5. Clear? Yes or no?
Yes, yes.
Now you have to add these two according to the addition operation provided here. So this would be x plus minus x would be 0, y plus minus y would be 0, 5 plus 5 would be 5. Yes or no? Getting this? Are you getting this? I have followed this addition operation.
So according to the definition, new definition, we have to consider the third
Yeah,
component as
and
always 5, whatever operations we are doing, right?
yeah. So now tell me, you have got this element as z. Now tell me, is this 005 this element belonging to the original set? 0 is a valid real number. Okay, 0 is a valid real number, and you have 5 here. Okay, so
Yes.
005 actually belongs to the set. So the 0 element of this set is, what is it? It is 005. So
Yes.
this is false. B actually has a 0 element. Okay,
Yes.
so what is the 0 element? 000 is not the 0 element. This is
0,
wrong.
0, 5.
005 is the 0 element. Clear?
Yeah, clear.
Okay, for this, therefore any real number C, we always have C is equals to 015. So just perform this operation. This will be 0. C times 1 will be C. This should have been C, but this is 1. So this is not true. Clear? This should have been C. C times of 0 will give you 0. Clear? C times of 1 should give you C, but it is 1. So this is not true. Clear? Yes or no? From this operation.
Yes.
Okay. What about this? For each element, V belongs to V. Okay. And for each pair A plus B, A and B are real numbers. This is real number. This is real number. Okay. You have to check whether this A plus B times V is actually equal to AB plus BV. Okay. So what you need to do is just pick any general element from from V. That is this set V. So let's take PQ5. Okay. So PQ5. Okay. And you have A plus B, some scalars. So I know I will distribute it. So it would be A times of PQ5 plus B times of PQ5. And on RHS you have to check. So this is A times of, okay, sorry, you don't have to check that. You actually have to do, okay. Because yeah, what you have to do is you have to scale this vector by A plus B. So this will become what? A plus B times of P, A plus B times of Q. And so what they are checking is, this is known as checking distributive property. So distributive property, they are checking that. So okay, so this will become 5. Yes or no? Because C times of xy 5 is Cx Cy 5. So this is A plus B P, A plus B Q 5. Now what about RHS? RHS is A times of PQ5 plus B times of PQ5. Now you have to add, first of all you have to scale this vector by A, scale this vector by B. So this will become QA 5 plus PB QB 5. Now you have to add these two vectors. What will result in this? P A plus B, then Q A plus B, and what you have, and adding using this operation you will get 5. So is LHS equal to RHS? Yes. Okay, so this is true. Clear?
Yes.
Yes or no? Okay. Now this question, now you directly have to calculate A square and equate it to 0 and you will get C and D. Clear? So let's do it. 1 by 3 CD, 1 by 3 CD is equals to the zero matrix. Okay, always remember this is a zero. Whenever it is written zero, you have to check whether you have to cleverly like see it's a zero matrix. So this will give you 1 plus C by 3. Okay, 1 plus C by 3. Then this will give you 1 by 3 plus D by 3. Then this will give you C plus DC. Okay, this will give you C by 3 plus D square is equals to 0, 0, 0, 0. Now see, first of all, yeah, so C is nothing but minus 3. Yes or no? From this first equation. So there are four simultaneous equations. One more thing, whenever you have a matrix like this, so there are four simultaneous equations. Okay, because you have to find solutions such that all four are simultaneously satisfied, because it could happen that suppose C is equals to minus 3 comes from one equation and you get happy, but from fourth equation there comes C is equals to minus 3 and C is equals to plus 3. Then in that case you have to eliminate one of these. So that's why this is a simultaneous system of equations. You cannot just like find, okay, I'll show you. So D in this case from second equation is D in this case. So 1 by 3 plus D by 3 is 0. So D is minus 1. Yes. So you might get happy here and just stop calculating. Yes or no? But you have to check the other two equations also, because this is a simultaneous system of equations. So C is minus 3. Okay. And what is D? D is minus 1 and C is minus 3. So this is giving you fine. So this is being satisfied. What about this? C by 3 plus D square is equals to 0. Now if you had not used this equation first and used this equation first to calculate D square, to calculate D, then this would have given you C is minus 3. So this would become 1. Yes or no? Now this would give you two values, D plus minus 1. Yes or no?
Right.
Yes or no? Now you would have to eliminate. So see, since there is only one value for C, good. So I no need to worry. Now there are two values of D, 1 and minus 1. So I have to eliminate one of those. So what we will use? You will use this third equation. So C is minus 3 plus what is D? If I take D as 1 and C as minus 3, then what I'm getting? I'm getting minus 6. So D's value of 1 is not a valid value. Clear?
Yeah.
But if I take D as minus 1, then it is being satisfied, this third equation. So are you getting why I'm focusing on the simultaneous part, simultaneous system of equation? That is, I have to find solutions such that all the four equations 1, 2, 3, 4 are simultaneously satisfied. So if I take C as minus 3 and D as minus 1, this is satisfied, this is satisfied, but this fourth equation does not get satisfied. But if I take value as minus 1, then all four get satisfied. Clear? So if I take value of C as minus 3 and D as 1, then only three equations, this equation, this equation, this equation gets satisfied. This fails. But if I take C value as minus 3 and D as minus 1 here, then all four simultaneously satisfied. Clear? Yes or no?
Yes, clear. Yeah.
Okay, this should be very clear. Like, don't like think a lot before, like, see, the thing is, maths is not about finding answers, at least not in general. I mean, in objective exams, and I know everyone is in rush of finding exam answers, but see, professors are well aware of this. Okay, so they will expect you to do mistake. Only the naive people will do mistakes. Those who are very thorough with their concepts will step and ponder for a while that, okay, this is a simultaneous system, I need to evaluate every possibility. Clear? That's
Yes.
where the people with weak concepts will fail. Okay, so what is the value of C and D? C is minus 3 and D is minus 1. Clear? Not plus 1. Clear?
Yes.
Okay, so there is lots of intricacies in every question. I mean, this might seem very detailed to you, like how much detail we have to go, but if you are clear with your concept, this is very basic for everyone. Okay, so now this question, consider the system of linear equations. Okay, so we have this system. Does there exist an A such that system has infinitely many solutions? First of all, see that what is the system? This is a system in 3 equations and 3 variables. Yes or no? So also you can see that this B vector is 0 vector. So this is a homogeneous system. Yes or no? Ax is equals to 0.
Yes.
Now A is a square matrix. Yes or no? 3 cross 3.
Yes.
Yes or no? So does there exist an A? First of all, write A matrix. 2 minus 1 3, A minus 1 1, then 4 minus 2 7. Clear? This is your A matrix. Now it is asking, does there exist an A such that system has infinitely many solutions? If yes, find the value of A, else write as 100. Okay. So infinitely many solutions will exist when, first of all, you should know that this will always have a solution. Yes or no?
Yes.
So, okay, just read the second question. Does there exist an A such that system has no solution? Is it ever possible? Because I have a 0 vector here, it will always have a solution. So answer of this is 100. Because see, if it is written, if you can find the value of A such that it has no solution, I know that it always have a solution. Else write answer as 100. So this is 100. Clear? Second question. You know that a homogeneous system always have a solution. It cannot
Right.
be that it does not have a solution. Okay, so now first question. For this, you would have to perform row echelon conversion. Okay, so let's do it. Yeah, I can smell some fragrance. What is this? Fragrance. Okay, sorry. Yeah, so this okay. So convert it to 1. 1 minus half 3 by 2. Now I need to start cleaning down the pivot. So what will be the what will I do? A times of row 1.
Sir, why did you write 4 A
Where
4 in
I've
second
written A.
in
Oh, sorry,
first
sorry, sorry,
matrix?
sorry. This is minus 1. Yep. Okay, so what will I do? I will start cleaning down this pivot, so I can subtract A times of row 1 from row 2. So this will become 0. Then minus 1, uh, A times of row, A times of this row, right? So this will become plus A by 2. Yes or no? This
Yes.
will become 1 minus 3 by 2A. Okay. And this will become 4 minus, okay. Now I need to like 4 times of row. So 0, row 1. So for converting this to 0, subtract 4 times of row 1 from row 4, row 3. So 0. Then this will become 2. Okay. 2. This will become 7 minus 12. This will become minus 5. Okay. Now I have cleaned down this pivot. Now what I need to do is I need to convert this to 1. So what will I scale it with? 1 minus half minus 3 by 2. This will become 0. This will become 1. And so I'm writing this as 2 minus 3A by 2 upon 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 A by 2 minus 1, which is, so this I'm scaling by this, right? So A by 2 minus 1. Now for this last one, 2 minus 5. Now I need to clean down this pivot. So this will give 1 minus 1 by 2. Okay. First of all, to scale this by 1 by this part, one thing is sure. So see, I performed this scaling operation, right? Then I know I cannot divide by 0. So A by 2 minus 1 should not be equal to 0. That is A by 2. A should not be equal to minus 2. A should not be equal to 2. Okay, this is one condition. Now, so 3 by 2. Okay, 0, 1, and what was this? So this is 2 minus 3A. This 2 will cancel with this 2, so A minus 2, right? And you would have 0. Now I've started cleaning down this pivot. So 2 times of this minus this. So this will give you 0. Okay. Now I have subtracted 2 times of row 2 from row 3. So minus 5 times of minus 2 times, right? 2 times of this value. 2 minus 3a upon a minus 2. Okay. Is this clear? Now you can stop here. You can stop here. Okay. You need not, like, you can scale again, go on scaling down this with this only. So okay, you can just scale down. So what will this become? This will,
In this first operation, how you made A0? What operation you did?
in this.
Yeah.
So I subtract, first of all I scaled this with 1 by 2. Then okay, after scaling I subtracted 1 time a times of row 1, that is this new row, from this row. So I got 0. Okay, so now it is asking, does there exist an a such that system has infinitely many solution? So when does it will have infinitely many solution? When there is a free variable, that is this value should be not equal to 1. That is, it should not be 1. That is, it should be 0. Yes or no? Because otherwise it will become pivot.
Yes, sir. Inconsistent.
So minus 2 times of 3a by a minus 2, they should be equal to 0, right? Then only it will have like free variable, right? Because if it becomes 1, if it is a non-zero quantity, then there will be no free variables. In that case, you won't have infinitely many solutions, but a unique trivial solution. So in that case, it has to become 0, because it is asking infinite solutions. When does what value of a takes such that it has system as infinite solutions? So this will become 0. So let's say, so this is mine 5 by 2 is equals to 2 minus 3a upon a minus 2. I have transferred this here, then brought this 2 down here. So this will become plus 2, sorry, minus 5 by 2. Okay, minus 5 by 2. Now I just need to minus 5 times of a minus 2 is equals to 2 times of 2 minus 3a. Minus 5a plus 10 is equals to 4 minus 6a. So this will become a is equals to minus 6. Clear? A is equals to minus 6. So what is the answer? A is equals to minus 6. Okay, I need to check whether it is actually correct or not. Are you all following what I'm teaching?
Yes.
Okay, no, this is not the question. Enter, not enter. Okay, I've done 2. 2 is the answer. What I am getting? Okay, somewhere some mistake.
Minus.
Okay, yeah, I have done some mistake. Where, okay, some calculation mistake is there, but
An
I
easy way
hope
to
you are
do
getting.
this was,
Sorry.
sir, an easy way to do this was to put the determinant equal
Yeah,
to
that
0 and
is one
find the
way.
value.
Yeah, that is one way. Okay, so A's value is actually 2. I have done some mistake somewhere. I cannot find. So A value is actually 2. So okay, does there exist a system A? Okay, I will see it this at the end. I've done some mistake in calculation somewhere. Yeah, somewhere I've done some calculation. Okay, I will do it at the end. So now this question, W1. Okay, so this question, So you can see that this is a subset of 3 cross 3 matrices. Okay. Yeah. So whoever pointed out that determinant is an easy way to do, yeah, that is correct. But what if like this equation was not given? Then you would have to follow this. Okay. So if determinant is given, I mean, if it is a 3 cross 3 matrix, then very good. That is a much shorter way to do it. But if it is like this equation was not given, then also they could have asked you this question, and then you would have to follow this methodology. Okay, clear? So I hope you are getting both points.
Yes.
Okay, so good that you pointed out. Okay, so this question, W1 is a subspace. Okay, it is a, no, I mean, not necessarily it is a subspace. You have to check whether it is a subspace or not. So what is the first criteria I told you? Always check whether 0 0 0. So what is the 0? So this is the parent subspace, parent space, vector space. That is all 3 cross 3 matrices. So pick the 0 element of this and check whether that 0 element is a part of this. So is 0 0 0 0 0 0 0 0 0 matrix part of this set? So it is a set of matrices A, B, C, diagonal matrix, such that A plus B plus C is equals to 1. So is 0 0 0 0 matrix part of this? No, because if you check 0 plus 0 plus 0 is not equal to 1. So this W1 is not a subspace. Clear? Yes or no? Yes or no?
Yes. Yes.
But okay, that is one good way. Now for your like quest 2, okay, no, not okay, forget about it. Okay, so this is not a subspace, that is for sure. So what is the answer? It is 0, because they have written find the dimension, else write the answer. Okay, so one more thing, when you have these sets given, there is a special name for these subspaces, these sets, that is known as affine subspaces. Okay, there is a special name for this. Okay, but those affine subspaces also have dimensions. So if they had asked you if W1 is an affine subspace, then its dimension would be valid. Then you would have to write it. So let's do one thing. So I have told you, right? Whenever such set is given, there will be some condition given. First, you have to express one of the variables in terms of other variables. Then you have to write the general element. So what you have to do, C is equals to 1 minus A minus B. Clear? Then you have to write the general element here. So A 0 0 0 B 0 0 0. Now you have to replace the third element with 1 minus A minus B. Clear? Now you can see how many letters? 1 2. So you have to write 1 A B. Now with A you will write 1 and rest all 0 places. 0 0 0 0 0 0 0. What will be here? What will be here?
Minus 1.
Okay, one more thing. If there is a constant here, forget about the constant for a while. Just forget it. It exists. Okay, just forget it. Now tell me what should come here? Sorry, what should come here? Forget one exists. Okay, just forget it.
Minus 1.
Then what should come here?
-1.
-1. Clear? Plus B. Now same for B. 0 0 0 0 1 0 0 0 0 0
Minus 1.
-1. Clear? Now you would account for this constant. That is, just write a matrix 0 0 0 0 0 0 0 0 1. What if there was a 5 here? Then again you would ignore this constant. You would write as it is, and if there was a 5 there, then you would write a 5 here. Clear? So constants you would account at the end. Clear?
No.
What? So
Sir,
see,
what happened in the last?
in this general element, see the letters and ignore the constants. Okay, so if there was a 5 here, so you would ignore this constant and assume it to be 0. Okay, now you would go on about your regular business, whatever you do. Suppose it was 5 here. Okay, that is, it was 5 here. So then you would see how many letters are there. 1 2 unique letters. So A I've written, B I've written. Now what you do, you will follow the same method. In place of A, place 1, rest all variables 0. So 1 0 0, I have ignored this 5 here. So 0. 0, 0, 0. In place of B, I place 0, 0, 0, and -1. I have ignored this one. Same for B. Then at the end, I will account. So at the end, I will account for the constant. So 1 will come here and 5 will come here. Clear?
Yes, sir.
Okay. So right now there is no 5. It was 0 only. So 0. So now you can see that this part is actually a subspace. And this is a constant. So in your week 7, you will see that an affine subspace is nothing but a subspace plus a constant. Okay. So this affine subspace is, so dimension of an affine subspace is same as dimension of this subspace. Okay, which is there are two basis values. So this is actually, see, the thing is, what is an affine subspace? Suppose you are in R2. Okay. You know
How
that
we are getting -1 in that subspace diagonal value?
what?
How we are
See,
getting -1
there,
in
so
diagonal?
first of all, forget there is a 1 here. Now I told you that there, in place of A, you will place 1. So there is a minus in front of it. That's why it's -1. And B, you have placed 0, so it will be 0. Clear? Similarly,
1,
B,
yeah,
you
1
see,
minus
first of
A
all,
minus B is the value, right? So 1 we
yeah,
have
first
to,
of all,
you know,
first of all, I told you that if there is any constant, so 1 is a constant. Forget about it. It exists. Just assume it to be 0. Now in place of A, so this is basically in a sense minus A minus B when you are calculating. So this would be -1. Okay. Similarly,
okay.
this would be -1. Now see, what is an affine subspace? So see, you know that a line through R2 from origin is a subspace. Now what is an affine subspace? An affine subspace is nothing but just a translated version of the same line. That is, it has been shifted. So there is some constant point here. So it has been shifted such that it passes through that constant point. So affine subspaces are linear translates, are translates of the subspace. So this is a subspace and I'm adding a constant to it. This is a constant matrix. Okay. So clear?
Yeah.
Okay. So if they have asked if W1 is a subspace. I know W1 is not a subspace but an affine subspace. So they have asked you if W1 is a subspace, find the dimension, else write the answer is 0. So answer is 0. What is the dimension of this affine subspace? Dimension of an affine
2.
subspace is same as the corresponding subspace of which it is a linear translate of. So this is a translate of a two-dimensional subspace. Okay. So this is the subspace part and this is the constant part. So you can see that this subspace is being translated by this matrix. So if they had asked you if W1 is an affine subspace, find the dimension. So in that case, it would be 2. Clear? Yes or no? Yes or no?
Yes.
Huh? Sorry.
Yes.
Okay, now this question. Now see, A, B, C, 0, 0, 0. Now they have not given you any condition, any equation here. Oh, okay, they have given. Okay. Okay. So see, they have given you this. Always pay attention to this. A is equals to B is equals to C. Now, when you have to write general element, you have to replace every element because they are all equal. So you can write A 0 0 0 A. Clear? You have to reduce as much element as in this general element by using condition given here. So here in previous condition, you can only eliminate one element. So that's why C is equals to 1 minus A minus B. Clear? But here you can eliminate two elements, B and C. So that's why I've written this general element by eliminating B and C. So A. Clear? Now, how many letters you can see? 1. So A, 1, 0, 0, 0, 1, 0, 0, 0, 1. Clear? So what is this dimension of this subspace?
1.
1. And this is actually a subspace. Okay?
Okay.
Now what is the, now see, they have not given you any condition here. In this, they had given you this condition. Now they have not given you any condition. Clear?
Yes.
So you have to write the general element directly. You cannot do anything. You cannot eliminate any element. So now you have, how many letters you can see? 3. So what will be the dimension?
3.
0 0 0 0 0 0.
Clear? So there are 3 basis vectors. So the dimension is 3. Clear?
Yes.
Okay, now this question is a bit good one. Okay, so what uh, see, I won't do this here. So if you are able to, like, this was a multi-part question. You have to find A, B and C, and this was carrying a lot of marks in the Jan 24 term. Even I took some time to uh, do it. So I will give this to you to do it. But I will just, what I will do after the session, I will jot down the solution and give this PDF. Okay, you can see it afterwards, but I would advise you to, like, at least try it. Okay, this is a good question. Anyone, any idea? So see, they have not given you a matrix, but they have given you these 3 token of informations. AU is equals to U, AV is equals to minus V, A cube W is equals to ABC. Okay, 3 unknowns, 3 equations. So okay, I hope you will try this on your own. Okay, if you are able to do this, very good. Like, it would be very good. Okay, so I won't do this here. But I would tell you that you have to use these 2 equations first. Okay, yeah, just 5 minutes. Okay, okay, so I won't do this. Clear? Hello, am I audible?
Yes, sir. Yes.
Okay,
Yes, yes.
fine. Now these 2 questions. Okay, so is this in reduced row echelon form? Above pivot it is clear, above pivot it is clear. There is no pivot here, so need not worry about this. So this is in reduced row echelon form. The reduced row echelon form of any square invertible matrix is identity matrix. Reduced row echelon form, okay, that is true. Clear? Of a square matrix is identity matrix. So that is true. Elementary row operations can be performed only on square matrices? No, it can be performed on any matrix. Anyone wants to say anything? Okay, go on.
Yes.
If a matrix is in reduced row echelon form, its last row will always be 0? No, because you have identity matrix. Sorry, 0, 0, 1. In this, you can see that there is not a non-zero row. Last row is non-zero, so this is wrong. Okay, clear? Okay, now this question. They have given you 2 vectors
I
and
have one
V3
question.
vector. Yeah,
Reduced row echelon form of a square matrix can have a zero row at the last,
it
right?
reduced row echelon form of a invertible matrix,
Oh, okay,
invertible
invertible.
square
Okay,
matrix
okay, okay. I
will
know.
always be identity matrix.
Yes, yes, my bad.
Okay. Now this question. Now they have given you 3 vectors. Choose the correct option. If A is equals to 5, B is equals to 0, C is equals to -1. We set V1, V2, V3. Okay, this is same as that. Okay. You have to check independence of 3 vectors. So you will assume V1 is equals to some scalar plus some scalar. Then you will check whether those scalars are actually equal to this. Clear? Okay. Okay, so how you will do this? You will so they have given you a set, right, and they are asking you whether this is a basis. So I've already told you, you have to place them as columns in a matrix. You have to do reduce row echelon form. Okay, conversion, and then you will check. Okay, so you have to check it. Is this part clear? You can do all these questions, they are very basic. So this was the last question. Is this part clear? You can do this. Okay, at least do this. I have explained lots of questions.
Yes, sir.
Okay, so I hope this session was helpful.
It was really helpful. Thank you.
Yeah.
Thank you, sir.
Thank you, sir.
uh, okay, so I will share this annotated PDF with this question. Okay, definitely do this question. This is from Jan 24 quiz 1. Definitely do this question. If you are this question had 3 parts, and like this was like 10 marks or something. So uh, quite a lot of weightage. So do this. I will perform the solution in this and share it. Okay. Is this part clear?
Where will you share the PDF?
Secretary will tell you. I have no idea. Okay. Okay. So I hope it was helpful. Any
Yes,
feedback you
yes.
would like to provide?
Thank you so much.
It was really helpful.
Yeah. Sure.
You explained it in such a way that it's very easy to understand questions. Don't know how
Yeah.
much we'll be able to do
Yes,
in
sir.
the exam,
Now
but
we know how to
presently
apply
we will be
formulas.
comfortable.
Yeah. See, you cannot directly just learn all the formulas, because this is not based on formulas. Formulas can only be applied if you understood what is the hidden caveat in that question. Okay, then only you can apply formula, like equating determinant to zero. But you first should understand what the question is saying anyway.
Yeah,
You cannot like,
conceptually how we have to approach that you explained well.
yeah. Thanks.
Yes, sir.
Uh,
So can you share the
okay.
PDF in chat section?
Yeah. Chat section. How can I share the PDF? Right? You have to share messages or links. We cannot. Okay. One thing could be like uh, uploading it on Google Drive and then uploading the uh,
Link, sir.
link of it.
Yes, sir. That would be
Okay.
great.
How did this secretary contact you? Uh, you get the mails from him, right?
Yes,
In
sir.
So I,
Yes.
yeah, I,
meeting,
Yes,
meeting
sir.
you can add the drive link, right?
yeah, I can like ask him to mail you the drive link. Is it fine?
Yes, sir.
Uh,
That would be fine.
Yes,
okay.
yes.
Okay. Thanks for attending the session. I will end this meet now.
Sir,
Thank you so much for your time.
Yeah. Sure.
Thank you so much for your time, sir.
Yeah. Welcome.
sir, in the previous question, hello.
Yeah. Go on.
Sir, in the previous question, we have to express in it linear combination of W, right? By solving this equation which you have given.
See, first of all, you should know is A is not given at all. A is
Hmm.
not given to you at all.
Hmm.
So you should try to, and in one of the equations, I will give you a hint. One of the equation there is a cube. So you should try
Hmm.
to bring some sort of equality like in all three equations. Okay, just this is the hint I will give you. You should do it, like really you should do it. Okay, if you are able to do it, very good.
Yes, sir.
Okay.
Thank you, sir.
Welcome.
Please try to share the PDF
Yeah,
early.
sure. You will get the PDF.
Thank you.
Yeah.
Guys, you may leave. Session has ended.